session, we are talking about the program that basically concentrates on adding different number of bytes of data. The program should remain same whether I am adding 3 bytes or n number of bytes. So the program should be most general and it should be concentrating on the process of adding these data. Now let us see what is the required question. So here we are asking to add n number of datas and each datas are 1 byte each. The data format can be binary or it can be some other format too. Right? Depending on the format of data we are going to change, but we are not going to change the program depending on the number of bytes. So my assumption here is I am taking an external memory 8001 onwards. 8100 onwards, where I am putting the data that I need to add. I am ensuring that the first number, whatever I enter, indicates how many data I want to add. Say for an example, I want to add 1, 2, 3, 4 and 5. I have 5 data here. So I have 5 data to be added. So my first number, whatever I enter, is 5. I am going to add all these data and store the result in 9100. Okay, the destination and source choosing is completely left to the user because in the question it is not mentioned. So what am I doing? I know what is my source location. I am initializing that into DPTR. I am initializing one temporary register with 0. I will use R5 to store the carries. Suppose first 2 numbers are added, the carry is 1. Second 2 numbers are added, again carry is generated. I will increment that particular temporary register R5. Now, these are 2 initializations I basically do. Now, I know the first data is a counter. Now, whenever I have 5 numbers, how do I basically add it? I will add first 2 numbers. So, first addition. Answer with third, second addition, answer with fourth, third addition, answer with fifth, fourth addition. If you observe, for 5 datas, I have 4 additions to be carried out. So for n datas, I will have n minus 1 additions to be carried out. So that is what I am doing here. So I am fetching the first number, copying it into R7 and decrementing once because it is n minus 1. Now, R7 can be used as a counter. I am clearing carry. For sure it will be 0 just to ensure it doesn't contain any junk values. We are clearing the carry. Next, incrementing DPTR. The first data is fetched to A, copied to B temporarily. Second data is it is moved to the second data by incrementing DPTR and that is also copied to A. We are adding the first 2 numbers, that is 1 and 2 are added. Next, if there is no carry, okay, 1 and 2, 1 plus 2, 3, so there is no carry, so it will jump to L2. That means I am decrementing the count. If there is any carry, as I said, R5 is initialized to 0, it should be incremented. Okay, indicating there is a carry generation. So this process goes on, okay, this process goes on repeating for the count number of times. So here in this case it will repeat for 4 times. After that I am initializing the destination location. I am storing the content of A, which is the sum. I am incrementing, I am storing the content of R5, which is your carry. So first answer is sum, second answer is carry. In this case, even if I add in the hexadecimal number system, I do not generate any carry, hence my answer is 0. Hope you people have understood the logic behind this program. Now let us just execute it in Keel and check how it basically works. I am going to Keel. So in the Keel, in the Keel software, okay, I'll just save my program. The procedure is same. I have created the project. I have selected the hardware that I need as a normal process. And I have typed the program and I have saved the program with an extension .asm. After saving the file with .asm extension, I have added that file to source group. You can see day5 is an experiment that I have saved here. Hoping that I haven't typed anything wrong, let me save and go for translating it into binary form. So I have translated. It's good that I'm getting 0 warnings and 0 errors here. So I'm getting 0 warnings, 0 errors. So that indicates I can move to the next step. In the next step, basically, I am trying to link the program, whatever I have written in binary, it is now converted. Now I will basically go to translate. After translate, it is build where we are trying to link the hardware characteristics. Next, I'll go to debug. So on debug, where should I give the data? Just see the program 8100H. I'll give the data as 1, 2, 3, 4 and 5. After giving the data, I am running the program. So I'll have to go to 9100H and you can basically see the result. Okay. The numbers have been now added. Hoping you people have understood this process. Okay, the same logic can be applied for BCD addition or decimal number addition. This is basically an example of hexadecimal addition. Okay, thank you so much.